So chapter 6 on engineering mechanics statics is about structural analysis, and in this chapter we're gonna discuss trusses. So this chapter is divided into 4 sections. In section 1 we're gonna talk about simple trusses, and basically to solve simple trusses there are two methods, method of joints and method of sections. So in the section 6.2 we're gonna discuss method of joints. And also it's important to understand zero force members because some of the members do not carry load, and it's important to understand these zero force members because these zero force members increase stability of whole truss. Okay, so last section would be on method of sections. So what is a truss? A truss is a structure composed of slender members joined together at their end points. So basically a truss is a structure that is composed of slender members. A slender member is a member whose one dimension is comparatively much longer than its other two dimensions. So basically a rod would be an example of a slender member. So a truss is a structure that is composed of slender members joined together at their end points. So what could be an example of a truss? So let's just see, for example, this is a bridge and it's helping for some loads to travel from one place to another. It could be people, it could be a vehicle or something. So this bridge is composed of floor, beam, stringers, deck, but the whole load carrying structure is, main load carrying structure is this bridge truss. So if you take a cross section of this, you can get this simple truss, and you can see that this truss is composed of different slender members. So this is one of an example of a slender member because this, it has a one dimension which is comparatively longer than other two dimensions, and these are the joints from where it's transferring the load. So this is an example of a simple truss. This is also an example of a truss. There are 3 columns, and these columns are supported on this roof, and this roof is also made up of series of trusses. So this is an example of truss, and I have shown this the cross section of this roof here, and this is an example of a roof truss, and these are its slender members and they are joined together at joints. So this is how a truss of a structure is defined. Now these slender members are joined by some of the connections. So for example, this gusset plate connection is one of the famous connection which is used in trusses widely. So basically it's these are the members, and these members are combined by this gusset plate. So basically this gusset plate is welded or bolted on these riveted on these members, and this is an example of pin. So this is a pin, and all these 3 members are combined on that pin. So basically in order for a truss to work, we need to identify 2 assumptions. So there are 2 assumptions for a truss. One assumption is that all the loadings are applied at a joint, and it makes sense, right? Like this assumption says that all the loads has to be applied on the joint, and the second assumption says that the members are joined together by a smooth pins. So why these assumptions are important? Because these assumptions says that, for example, this is a point and the members should apply force on these points. Now what will happen if the members will not apply force on these points? Then, for example, if a member is applying force somewhere other than a point, so it will generate moment, as we have discussed in the previous chapters, and we don't want moment to be generated in a truss. So that's why we assume that all the loadings are applied on a joint. Now, because of these 2 assumptions, each truss member will act as a 2-force member. And we will talk about these two force members, but the idea is that we should not have a moment, because if we will have moment, we need a material to resist that moment, and we want the trusses to only carry one of the two force members to simplify our problem and to make design more efficient. Okay, so the truss which we will be considering in this chapter are called simple trusses. So we'll discuss simple trusses in this chapter, and the simple trusses are trusses that are constructed by expanding the basic triangular truss. So there could be many examples of trusses, but in this case we are discussing simple truss, and simple truss would be a truss that is composed from basic triangular trusses. So basic triangular trusses means that we need to have a triangle, and if there are so many different triangles and we are making a truss by using only triangles, then this type of truss would be called a simple truss. For example, this is a triangular, basic triangular truss, and on the top of this basic triangular truss we have added another basic triangular truss. So if this is the case and we built a big truss by making use of these basic triangular trusses, then this kind of structure would be called as a simple truss. Now there could be other examples also where we don't use basic simple trusses and it's like bunch of different trusses together in a three-dimensional space, or if one truss is combined with another truss in a complicated way, then this would not be called as a simple truss. So in this chapter we're going to just discuss simple trusses. Now all these trusses have joints and they also have these slender members. Now these slender members, as we have discussed before, are two force members. Now what do we mean by a two force member? A two force member is a member that has either tension or compression. So these are the two forces which are there in a truss. What is a tension? A tension is something that would elongate a member. For example, in this case, this is a member and this is a force which is acting on that member. And this type of force which is trying to elongate this member is called tension force. And a compressive force, on the other hand, would shorten the member. So this is a member and a force is applying compression and it's trying to shorten the member. So this kind of force would be called a compressive force or force of compression. Okay, now let's talk about this method of joint. So in method of joint, we have to solve this truss. So this is an example of a truss and we want to solve the truss. So what we want to do is that we will try to find what are the support reactions, and also we will try to figure out what are the forces in these slender members. So either the force is in compression or in tension. So we'll try to figure out which of the two force members is all these forces. Okay, so what does method of joint say? Method of joint says that we have to isolate these joints and then try to figure out what are the forces in these joints. Now, what do I mean by that? Let's just try to understand this by doing an example. So in this method, we're going to find all the forces. So the first step would be to isolate a joint. So in the method of joint, we will isolate a joint. And there are three joints. One is at A, one is at C, and one is at B. So looking at these three joints, let us just try to isolate the easier one. So in this A, it's the joint A is having a support which is a pin support. So we know that in pin support we have two kind of reactions, and this at C is a roller support. So we know roller has one reaction. So I will call this reaction AX, I will call this reaction AY, and I will call this reaction AC. Now there are a lot of unknowns at A also, at C also. So the B looks easier. So we'll try to isolate B. So how we will isolate? We will put this point. This is our point B, and there are two forces acting on that point from these two slender members. So this member is also applying a force. We can assume it as a compression or tension. It depends. So there is another force acting here. So it doesn't really matter which direction you are pointing, you're going to get the result. So if you have directed a wrong direction, then you will get a negative result. So you can change the direction later. I will explain this. So let's just say one force member is applying force here, another force member is applying force here. And you have, so these are the forces being applied by these slender members. And then you have a force of 500 Newton. Okay, so I will call this force as force of a slender member going from B to A, because this is between BA member. So this is FBA. This force is F of BC, member BC. Okay, so now we have isolated one joint. So now this method says that now you can find these internal forces by using equilibrium equations. So what were the equilibrium equations? Since in this truss, we don't have moment. So the summation of moment is equal to 0 could not be applied because we are assuming that there are no moments. So all we have to do is apply the summation of forces is equal to 0. So there are two summations of forces. Summation of f of x is equal to 0 and summation of f of y is equal to 0. Now, one more thing which is very important is that how we will know that a member, slender member, is in compression or in tension. So one of the assumption is that if this force we will calculate is pushing or pointing towards the joint, then we can say that this is a compressive force. And later it's going to get clear why it's a compressive force. But for now, you just have to remember that if it's directing towards the point, so for example, FBC is directing towards this B point. So if that's the case, when we get the result and this result comes out to be positive, it means that the direction which we have pointed was correct. So in that case, if this force FB is pointing towards the joint B, then it's a compressive force. And similarly, if the force is directing opposite, it's going somewhere away, for example, in the case of FBA, then it would be a tension force. So we'll understand this. So let's just do f of x is equal to 0. So how many forces are acting on x-axis? This force is acting on x-axis, and we also have to make an assumption. So we are making an assumption that all the forces acting horizontally would be positive. So this is an assumption we are making, and we're going to solve the equations accordingly. So this is a horizontal force, 500 Newton. So we will put a positive sign with this. And there is another force, this one. And okay, so this is 45 degree, this is 90 degree. And since we know that the summation of all the angles in a triangle are 180 degrees, so if you do the math, you will get a 45 degree. So this is resolved. Now we have to resolve this into two components. One is horizontal component and one is vertical component. And we can see that here it's horizontal. So this would be its horizontal component, and this is his vertical component, and this is 45 degree. So horizontal component is directing in the left. So what we will do is that we'll put minus because it's in the opposite direction, and its horizontal component is f of BC sine of 45 degree is equal to 0. So if you will try to solve this, you will, this will go there, and then sine 45 will be divided. So okay, let me do this. So 500 Newton is equal to f of BC sine of 45 degree. So f of BC is equal to 500 divided by sine of 45 degree. So f of BC is equal to 707 Newton. If you calculate this, it will come out to be 707 Newton. So remember, we assumed some direction before. So we assumed it towards the B, and it comes out to be positive. So it means that whatever assumption we made was correct. So this is a compressive force. Why? Because the force is acting towards the point. So this is a force of compression. Okay, now we know this force, which is 707 Newton. Now let's just try to calculate another force. And how we will calculate the another force? We will use we will use condition of equilibrium, that is summation of all the forces in y direction is equal to 0. So if you do this, we know f of BA is directing downward, and our assumption is everything which is upward would be positive. So this force would be negative. And now what is the vertical component of this f of BC? Vertical component is directed upward, and this would be the vertical component. So if you solve this, you will get f of BA as 500 Newton, and it's giving us a positive result, which means that whichever direction we determined was correct. So we just randomly assumed it was downward, and our answer is coming to be positive. So it means that our assumption was correct. And if it's downward, it means it's not pointing towards this point B. So this is a tension force. Why it is a tension force? Because it is directing away from the point. Okay, so now we have these two forces. Now we have solved everything at the joint B. Now we can move towards next joint. So either we can move towards joint A, or either we can move towards joint C. So to me, the joint C looks a bit easier because here you only have one unknown, but if you will go to the joint A, you will have two unknowns. So let's just try to solve joint C. So let's just say this is a joint C, and how many forces are acting on the joint C? So you have one force, which is A of C. This is a reaction. And now you have two forces. One is, this is an internal force, F of CA. And I have just randomly assumed that it's a tension force. But we don't know. We're going to figure this out. And I know about this force, F of BC. And this one is compressive force. We have already determined this. So I know the direction of this force, and it is directing towards the joint C because it's a compressive force. And we also know the value of this compressive force, which is 707 Newton. Okay, so all we have to do is to find this force and this force. And we have two equations, summation of f of x is equal to 0, summation of f of y is equal to 0. So we have two equations, two unknowns, so we can solve this. So first I will do summation of f of x is equal to 0. And this would be minus f of CA plus 707 cos of 45 degree is equal to 0. So summation of f of y is equal to 0, right? Summation of f of y, summation of f of x is equal to 0. So in summation of f of x, this force is this force, and which other force is acting on the horizontal direction? This force, right? So I have resolved this into a horizontal component, and if you solve this, you're gonna get f of CA is equal to 500 Newton. So you have solved for the f of CA. Now second would be summation of f of y is equal to 0. So how many forces are acting on y? One is AC, which is the reaction, and another one is f of BC, but it's directed downwards. So we're going to put minus sign. So minus 707 sine of 45 degrees equal to 0. So our AC comes out to be, something like 500 Newton. So we have AC also, FC also. So we have also solved this joint. So we have solved for this AC, which comes out to be 500. Okay. So now we have to solve the last joint, which is joint A. So joint A is, we have two reactions. One is A of Y, one is A of X. And we have forces, internal forces. How many? Two. And in which direction? So we know that force F of BA is in tension. We have already figured this out. And the force AF of CA, which is this one, is also 500 Newton and also in tension. Okay, so simple, right? We have to do summation of all the forces acting on x-axis is equal to 0, which would come out to be, so A of x is 500 Newton. It's positive, so it means whatever direction we assumed was correct. So we assumed this way, so it's this way. Okay, so now our summation of F of y would be equal to 0. And how many forces are acting on a y? F of BA, which is 500 upward positive, AY upward positive is equal to 0. So AY comes out to be minus 500. It means whatever direction we assumed was upward, right? So yeah, so whatever we assumed was incorrect. So actually this force is not acting upward, this force is acting downward. So if I draw actual, there is one force which is acting horizontally, there is one force which is acting vertically, there is one force which is acting A of x 500, and this force is actually downward, which is 500. Because the answer comes out to be negative, it means the direction which we assumed was wrong. Okay, so this is how you solve for method of joints. Now the next section is about zero force members. So it is also important to understand what are zero force members, because truss analysis using the method of joints can be very greatly simplified if we can first identify these members which support no loading. So these zero force members are those members which do not support any loading, and these zero force members are used to increase the stability of a truss during the construction and to provide added support if loading changed. So these members are those members which support no loading, and they help to increase the stability of a truss, and also it provides the added support. Now let me give you some example. So let's just say this is a truss, and this is also a simple truss because all the members are joined in such a way, and it has two support. One support is here and another support is here. So if you draw a free body diagram of joint A, it comes to be like this. So how to figure out like which members among all these members are zero force members? So one way is to do all the method of joint, and then whichever force will get 0, then you can figure out, okay, this is a zero force member. But just by looking at a truss, you can also try to understand which one are zero force members. Now how to know? If now the about zero force members, if only two non-collinear members form a truss, so you have to see all the members of a truss which are composed of only two nonlinear members, and I will explain this later. And no external load or a support reaction is applied to that joint. The two members must be zero force members. So how to know the members are zero force members? First we have to see that the truss, the joint, so we have to look at the joint, right? If only two non-collinear members form a truss joint and no external load or support reaction is applied. So there are two things. One is only two and another one is no external load or support reaction is applied, then these members are called zero force members. So what is a non-collinear member? So for example, if this is a line and you have two members on the same line, then these members are collinear members. So collinear means that all the members are not at the same line. So this, for example, this is a line for ED slender member, and this is a line for CD. So these are not passing on the same line, they are passing on different lines. So this is a non-collinear member. So basically all the members are collinear members. Now we have to see joints, all the joints. So in order to find zero force members, we have to look at the joints. And the first condition is only two non-collinear members form a truss joint. So which are the members in which only two collinear members are forming the truss? D is a point because D joint has only two members. C has three members, so it's not. E has 1, 2, 3, 4 members, so they are definitely not zero force members. It also has so many members. It also has so many members. Joint A also have only two members. So D and A qualifies this first condition that only two non-collinear members should form a joint. Now, what is the second condition? Second condition is no external load or support reaction is applied. Okay, so which are the, so no external loads. Joint C has this external load P, so it does not qualify. Joint B and F has support reactions. So it has a roller support, it has a pin support, so they also don't count. E also doesn't count because it has 1, 2, 3, 4 members. So A and D are those joints which have only two members and they also have no support and no external load. So we can assume, we can consider from this that joint D and joint A is a joint that has zero force members. So this member, let me change the, so this member and this member and this member and this member are zero force member. And if we apply a method of joint, and we'll get the results, and we can conclude that it's a zero force member. So this member, this member, and this member and this member is a zero force member. And let us try to do a method of joint on this joint A. So if we take out this joint A has two forces. This one is one force, this one is another force. This is F of AB, this is F of F. Okay, so if you do summation of F of x is equal to 0, how many forces are there on an x-axis? No force, just F of AB. So F of AB plus nothing is equal to 0. So we know this force is 0. If you apply summation of F of y is equal to 0, so you will again come to the same conclusion. So that's how, by just looking at it, you can also try to understand which are the members as zero force member. So if you know, then you can simplify the method of solving these trusses. Okay, so last section is about method of sections. So method of section is also another method in which you can find the forces, and this method is also used where you don't have to find all the forces, and if you are interested in some of the forces, then you can find by using this method. So what does this method suggest? So before trying to use this method of section, you just have to figure out the reactions at the supports, and you can find this by using equation of equilibrium. So let me draw the reactions first. So at A is a pin support. So in pin support, you have two reactions. And at roller support, you have one reaction. So before going into the method of section, we have to calculate these forces. So this is A of x, this is A of y, this is D of y. And I have just randomly assigned the direction, and when we'll get the result, if the result is negative, so that would mean that the direction which we have assumed is wrong. So we'll just change the direction. Okay, so first let's try to find A of x, A of y, and D of y. So how we will find that? We will do summation of all the forces acting on x-axis is equal to 0. So it will come out to be, if you do this, then it will be like one A of x is this direction, and what another force you have 400 Newton. So it will come out to be A of x is equal to 4. This is positive, right? Because this is also on horizontal direction. So you will come out to be minus 400 Newton. It means that the assumed direction was wrong. So actually the correct direction of A of x is this way, A of x. So this is 400 Newton in this direction. So this is A of x. If we do summation of f of y is equal to 0, so how many forces acting on the y direction? Oh, actually so many. You have ay also, you have dy also. So if you will do this, you still need another equation. So you have A of y plus d of y and minus 1200 Newton is equal to 0. So you cannot solve this because you have to no. But what you can do is that you can apply summation of moment. So let's just try to apply summation of moment at point A. So if you will apply summation of moment at point A, so what you are doing is that you are trying to find the moment. So this A of x and A of y becomes 0 because there is no distance. The distance is 0. So 0 multiplied by A of x or 0 multiplied by A of y would be 0. So you have 3 forces remaining, 1, 2, 3. And this, let's just talk about this 1200. This 1200 is clockwise, and we have assumed anti-clockwise to be positive. So clockwise means 1200. So clockwise is negative. And what is the distance? 8. Which one? So we have done this. So which one is the next force? Next force is also clockwise. So minus 400 into what is the distance from the line of action of force to this axis of rotation? 3. And the last force is anti-clockwise because it's gonna rotate the joint anti-clockwise. And we have anti-clockwise positive. And what is the distance between the line of action and the axis of rotation? 4, 8, 12. So if you solve this, you will get d of y is equal to 900 Newton. And if you put this d of y here and solve this equation, you can also get A of y, which is 300 Newton. So you have these forces, which is written here. A is 400 and another one is ay is 300 and ax is 400. And also the directions, the direction is this way. Now what we can do is that we can apply a method of section. So what method of section says? And by the way, the question is that we have to determine the force in member GE, GC, and BC. So what are these members? This is member GE, this is member GC, this is member BC. So basically we are interested in these 3 members. So method of section says that whichever members you are interested in, you just have to make a cross section, make a section, and then expose those forces. So I'm gonna cut whole of this, and in method of section you have to just put a vertical line and expose the members completely. So either you can cut it like this or cut it like this or cut it like this. So since we are interested in GE, GC, and BC, so I'm gonna cut it like this, and I'm gonna expose the forces as shown here. So these are the forces FGE, FGC, FBC, which we are interested to find. Okay, so how to find? Now we're gonna look at this figure, because this figure was used to determine the reactions, and now we have determined the reactions, and now we're gonna see how we can find FGE, FGC, or FBC. So similar, we have to use equilibrium equation. Summation of f of x is equal to 0, summation of f of y is equal to 0, and summation of moment is equal to 0. So if we do summation of f of x is equal to 0, we'll get three forces, right? Because this is also horizontally acting, this is also acting horizontally, this is also acting horizontally. So it looks a bit complicated, or you need to like do a lot of math to solve this. If you apply vertical forces is equal to 0, then you will have this one 0, this one 0, so only f of gc will be there and 300 would be there. So you can do this as well, I guess so. Yeah. Okay, so let's just do summation of f of y is equal to 0, and upward would be positive. So how many forces are acting on y direction? One is 300, this one, and another one is this one. All the forces are acting on horizontal direction. So the vertical component for f of gc would be 3 by 5 and f of gc, right? You have 3, you have 4, you have 5. So 3 by 5 would be a vertical component of f of gc is equal to 0. So if you solve this, you will get f of gc equal to 500. And I'm getting positive results. So it means whatever direction we assumed was correct. So we assumed towards the f of gc, so towards the joint. So towards the joint f of gc. So it's a compression force if it's towards the joint. Okay, now how to solve the other two components? Now you have three options. Either you can take summation of f of x is equal to 0, or summation of f of y is equal to 0, or you can take summation at any point equal to 0. Summation of moment at any point is equal to 0. So if I take summation of moment at point C, then you can see that I will get f of gc is equal to 0, f of bc is equal to 0, because it will be multiplied by a distance which is 0 in this case. So let's just take summation of moment at point C is equal to 0. So if I take moment at this point, so a would also be 0, a of x, because a of x, this is the line of action of force and it is passing from that joint, so it would be 0. So you have 300 Newton and the distance is 8. And is it clockwise or anti-clockwise? It is clockwise. So clockwise means you have negative with this. And another force is anti-clockwise, positive f of ge, and the distance is 3 is equal to 0. So if you solve this, you will get f of ge is equal to 800 Newton. 8 multiplied by 3 divided by 3, so it would be 100 into 8, 800 Newton. Similarly, if you want to try to find force FBC, so what you can do is that you can apply moment, summation of moment at point G. So if you apply summation of moment at point G, so these two forces will be 0, and then you can find f of BC. So if you do this, you will get f of BC is equal to 800 Newton as well. So that's how you can find the forces by using method of section. So this is chapter 6, and see you in the next chapter.